Hi, Sakul. How are you?
So, Yogesh, is this week the um the what is it, regional summit?
Uh,
Yeah, yeah, it is. It is.
maybe. I don't remember actually. Let me check. Maybe.
No, it is. It is.
Do you know, Sakul, it is?
Yeah, yeah. It is. It is. So
Anil is traveling, I believe, right?
yeah, 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 yeah. He's traveling. So I think it's done now. But yeah, yeah. People would be returning back.
Oh, okay. Yeah, that's a good call out. We'll see. Rama said he's not going to make it today. And I know Shubda was traveling for some other conference.
Uh, CXL DevCon. So I saw her there. Yeah, we spoke. Met.
Oh, okay. Yeah.
Yeah,
Right.
I
yeah.
see. Yeah, I guess my
Yes, I know.
question is really, are we going to get to critical mass today, right?
Yeah, I know what you get. That's what I'm
Yeah.
saying. And I know I also got back just yesterday, and so did Drew. Drew is here now, so we may want to, end the meeting early. Hey,
Run while you can.
Bilal just reminded me that this week was the regional conference and CXL DevCon and our BTS, where we came from. Me and Drew were at BTS, Willis I Tested Volume.
Oh, got it. Okay.
So just yesterday. So, man, Drew, I got to tell you, I'm sorry to bore everyone. My flight was super delayed. I got home like next day 3 a.m.
Oh, wow, I'm
Oh,
so
geez.
sorry. Wow, that's terrible.
Yeah, so I was so tired. Anyway, so yeah, we probably Rama is not going to make it. Anil, I doubt Shubda will make it either. Anil is of course traveling. He's in Europe somewhere.
Neil was just in a meeting with me.
Oh, okay. Let's see. Yeah,
Maybe
I
he's
was
back. Um,
okay.
but
Then maybe
I,
we'll wait for him.
I also did some. I wanted to show you kind of what I was thinking for uh, pulling the scenarios out, and the thing I'm talking about is what we agreed to recently. I'm not doing anything really weird, but I just wanted to show you kind of what I'm thinking, and and see if it makes sense to y'all. So, and the heart of what I'm trying to do is get the scenarios out of the document so we can get the document approved, and then have a separate place to update them. So, I was wondering if I could take a few minutes and review that, Yogesh, when you're ready.
Yeah, I think this is just as good as any other time. Why don't you? Why don't you? I don't expect any opens. So why don't you
Okay.
share? Yeah.
Yeah, and maybe we can make some progress closing some of the more benign comments, and we'll see if Anil joins.
Okay.
Okay, so I'm going to share a whole window. Let's see. Here we go. Okay, so let's hope they showed up. Okay, work in progress. So this is just our share drive, right? Nothing special. Work in progress. And then I think made something called scenarios. And then I created 3 documents. This one is an overview document that lists all the scenarios. This one is a template document, and then this is an example scenario. And I'll start with let me do one thing real quick. I just realized I didn't do. Okay, so
So which one are you starting with, the template?
I'm going to
Maybe?
start with the overview. So this is the scenarios doc.
Okay.
And what I was imagining we could do is organize it somehow. And it doesn't really matter because if it's organized with links, you can repeat a link. So I was thinking, air containment, what does poison recovery, poison containment look like? Um, we got PCIe scenarios, and I'm using heading, so maybe a little clearer here. There's memory scenarios, there's PCIe scenarios, and I don't even care if these are the right scenarios. I'm just trying to show, that we can organize it, we can create scenarios, and we can link the scenarios here. And what you would do is if you want to flesh out one of these scenarios, you just grab the template. And this is all that's in the template. I'm not being prescriptive. I'm just saying, name it and put your name on it and give an overview and give the details. It's if we want a more elaborate template, I welcome that. But I wasn't getting fancy. And then I took this straight out of the document, the in Bandera document, and I accidentally blew away comments. I'll recopy it and keep the comments because I think some of you all had really helpful comments in it. But that's my intent, is that we do this, and by putting them here, we can review them independently of the spec and approve them independently, and then we don't have to have this. And this is, I think, Suke, sorry, I blew away your comments and didn't mean to. So I'll copy them over next time. But do you see what I'm saying? Like this doesn't help us. I'd like to get this out of this document, and then maybe we can put we can have a link in this document to the table of contents and say, hey, if you want to see more fault scenarios that reflect this way of thinking, look here, and then you can pick the one that interests you, and you can click on that, and then open the one that interests you. So there's kind of a chain. So is that okay with folks? I'm just trying to
Yeah,
I'm trying to
okay.
break things up so we can move pieces independently.
Yeah, that looks good. So what does your template look like, Drew?
Oh, my template has nothing in it. I mean, it's you fill in the
Okay.
name of the scenario, your name, you give an overview, and you give the details. And
Yeah,
if we want
I
more,
think that's where we could maybe do a little bit of structure around the minimum stuff that we want to capture for each of the scenarios, right? Because if we don't do that, then it may be rant about a lot of things that can happen, or
yeah.
very little about this is how it flows.
I,
So
I agree. I just wasn't sure what we wanted to do. I was trying to at least agree on the
no,
concept.
I think I think you have the right approach. So yeah, maybe we can start offline filling in some of the template stuff and review it. So
Yeah,
that's
and another thing we
great.
might do is the other thing we could do is walk through an example scenario and
Mhm.
see, we can do both, right? We can work on the template, we can walk through an example scenario and say, here's what's good about the scenario, here's what's bad. Well, as we fix the scenario, we refine the template.
And basically scenario is same as flow, right? Same thing, right?
Yeah. It's just something we want to walk through. And I just chose scenario because it was very open-ended name. So I think it's any time we want to give an example, but we don't want to hold the spec up, but we want to have kind of a pile of tribal wisdom that we can come to that show how the flows work and how things work in practicality.
Right. Okay.
Okay, so what I'm going to do is I'm going to let's see, try to grab a link to this folder. I guess I do it this way. You can tell I've been away from Google for too long. Okay, so I just put a link to this folder into the document,
Right.
and or into the chat rather. And the other reason I wanted to do this is that this memory scenario is applicable to both the fault management team and the FMFM team. And so, that's the other thing that I like about this is that we can have multiple teams reviewing the scenario, giving their feedback, and that's fine. And that can be uh, owned by multiple teams, and we can all clean it up and make sure that, and it'll help us glue the work the teams are doing together, not just from, those of us that attend all the meetings. So I welcome feedback, criticism, questions, just let me know what you think. And, I hold this loosely, but I'm just, as I said, I'm trying to see if we can decouple things and move faster.
Right. So that does what your document must look a lot cleaner, almost done now, right?
Well, I mean, if I move this out, I didn't want to do it till we agreed. And I'm going to have to copy these comments back in to the, I've got a copy with the comments. But yeah, I mean, it gets rid of pages.
Most of the comments are, I think, kind of editing. So I don't think there's any substantial that this doesn't look
Oh, that's
like.
true. I'll review your comments, okay? And as long as
Instead
I
of copy, just click right on it,
Yeah,
all
you
of them.
you can just probably just click select or accept or reject. I don't think it's anything too like it's not changing the logic, is what I would say.
Oh yeah,
Yeah.
super nice. Okay, the most of them are used anyway.
Yeah, I agree. So maybe I think it just copied over the text, assuming I agreed with your changes. So uh, yeah, that's true. Okay, so I really don't need the comments. So if you all agree with my proposal, I will delete this section.
Anyone in opposition? If not, then we can clean this up.
Okay, and what I'll do is in the bottom, I'm going to take the table of contents document, and I'm going to put a reference. So OCP fault management scenarios, and I'll just say document. And I don't mean if there's another way people want to do it, but that way you can go look at the scenarios and it's linked.
Yeah,
I
for
think
the
for now
record,
we should
I thought
call
it
it.
was useful going through the different scenarios Drew. So
Yeah, and I don't want to stop that. I just don't want the scenarios to hold up the document. So, in fact, what I want to do is I want to ramp up the rate at which we do the scenarios. And I feel like if I can do them outside the document, I can just crank them out, kind of like as they come to me, and then we can review them and clean them up as we have time in the bigger meeting.
So for the references, should we call it instead OCP fault management work in progress scenarios? Because this document is going to be released probably imminently, right? And the scenarios, we're going to continue working on them.
So what we can do, Mita, is we can have scenarios a living document and add more links into it as they get released.
Well, and what we can do is mark each scenario as a work in progress too, right?
But I don't know how that will work with contribution portal. So yeah, I mean, I think yeah, we need to figure that out. I'm not sure actually.
You raise a really good point, Mita. And so what I'd like to do is I think this document is always going to be growing. But it's really a list of links. And so there may be some of the links that are works in progress and some of them that are not. And then, this is always a work in progress because it's a template. But then some of the scenarios will be approved and some of them won't. So we kind of need a way to, do it incrementally. And that's kind of the whole point is I can do it piecemeal. But then I guess, like we can submit the scenario as a contribution if we have to, or maybe we just tell people we have a pile of scenarios that you're welcome to look at. Some are works in progress and some are complete.
Yeah, I think that's fine that we just mark on top of each of them, whether it's a complete or it's a work in progress, then that should be good. We don't, yeah, that makes sense.
Okay, thank you. That's good
One other
feedback. I
thing
mean,
I
I'm
was
glad you
just
said
going to
that.
ask was that would this be the right place to also start adding in some, some definition around error injection? I mean, it almost seems like we're talking about different errors here. And I'm wondering if that, can just be like wrapped up in as we go through each one,
Um,
or is that something, you think is totally separate?
I don't know. Let me think about it. I think that here's what I'm going to do for the moment is I'm going to put uh, error injection here, uh, and then what I'd like to do, if you don't mind, is think about it, because like in this case, I don't think this is really saying there's a particular hardware failure and showing how it plays out as we change the access patterns in the OS and we change the data that's written to the memory. So there's not really an injection that's relevant.
Okay.
But I think you're absolutely right in that we should, talk about like how might you use error injection to test these things.
Yeah,
So
sounds good.
So I think at an absolute minimum, we need error injection scenarios. And so that seems obvious to me. Thank you. That was good feedback. And then I think what we're just going to have to do is on a scenario by scenario basis, see if we can determine how injection relates to it. So that's really good feedback. And I'm going to put that in the template. And I'll just say if applicable. Okay. Cool. And Mita, I love your feedback. I think there's probably other stuff that could go in the template. And so, I would encourage you if you want to just jump in and, put suggestions in the template. And I mean, not that I don't want the feedback now, but, like let's put it down and get people to review it. I think that's a great idea. Okay. Well, I was hoping that wouldn't be controversial. Uh, I'm glad it is.
Okay, so considering that we do not really have good quorum today, do we want to just, resolve the meeting early today?
Or we could go through one that Drew's already written, right? Or
Oh, sure. I mean, I don't mind. Or yeah, if we want, that's fine. Or we can do it later. Whatever you want. Do you want to do this?
Yogesh, were you saying not good quorum for the main document, or were you saying in general? Actually,
Either way, right? I mean,
Okay.
we want to do things when we can get everyone's view captured, which
Okay, gotcha. I thought you
I'm
meant
okay
the
either way.
main document. So yeah, fine. Yeah.
Either way, I'm okay. I mean, I'll let others speak up. What do you think, Vilas or Shakul or Suke?
I mean, I don't know. I'm here, so I don't mind. I feel like we've got. What's the quorum in general? Are you
Well,
okay?
I think it helps to have Anil for the in-band error discussion since he's the one that wants it. So I think that's part of the hacker quorum, right?
Is there a different section that we could cover instead?
Well, that's where Amita suggested the memory scenario I wrote, because that's not really about in-band or out-of-band as much.
Okay.
Yeah, I think it would help just to walk through this, and this should be quick, right? We could wrap up with this quickly.
Oh, you mean my memory scenario?
Yeah.
Hey, hearing someone from Micron say that warms my heart, because maybe it means you think I've got it right. I hope you've read it.
No,
So sure. Maybe we just go through part of it. I can introduce the scenario, and then if you want to walk through the details later, you can, but it's not that long.
Sure.
Okay. Well, so basically, I'll just assume we want to go through it. And I'll try to be pretty quick, and then we can just get feedback from you. But I was trying to think about, what's so confusing about memory errors? And there are a couple things that tend to trip people up. One is that sometimes we don't see a memory error because we don't access the memory. And the other is sometimes we don't see the memory error because when we access the memory, we wrote a 0 to something that was stuck at 0. So, or wrote a 1 to something that's stuck at 1. So, there's a chance you don't see all the errors because you happen to write the right value. And that's kind of contrived because it doesn't, you'll eventually write something that isn't right and see it. But I wanted to show that because, and the other thing that people imagine is that when you get a memory error, you either know enough to immediately figure out what's broken from one error, or you figure you can count the errors and say, oh, if I count them, that I can figure out that memory's bad. And basically, all those things are not right. You have to look at the memory, and you have to look at what's flipped, and look for patterns over time. And so that's what I'm walking through. And I'm also talking a little bit about how memory is pulled, how leaky bucket interrupts work, and how rate limiting might be applied. And unfortunately, uh, it took both Suke's comments and mine. It didn't do what I thought it did. I thought so. I'll have to clean this up. So if there are grammar problems, it's just because it copied the suggestions and the old text in. But anyway, so polling, you just read and log the errors at some regular interval. It gets you representative samples. It handles error storms, but it requires more overhead for software. Most polls are empty with no error.
Hey, just a general question on this one. We say error storms, Drew. Do we typically only refer to corrected error storms, right? It's not we don't
Yeah, and this is a corrected error scenario, really. So I can be specific.
No, you don't have to add that to that. I just wanted to know the nomenclature. Typically, when we say error storms, we're always talking about corrected error storms.
Well, it can be, you can have an uncorrected error storm, but you're not going to last very long. So, a lot of time, like an example of an uncorrected error storm would be memory fails hard, and you jump into a synchronous interrupt, like a machine check, to handle the error, and you're trying to execute code out of memory still, and memory is toast, and so the machine check handler tries to execute code, gets another memory error, you get a nested error, and now you're just dead. And so those storms tend to end pretty quickly. So corrected error storms is really what I'm talking about here. So it's a good clarification. And then leaky bucket, it interrupts after a certain number of errors occur, and you decrement a count of errors periodically you leak. And the problem with it is it hides errors until they occur fast enough, until they cross the threshold. But it's used to handle error storms, and it does handle error storms. And then rate limiting. And so with rate limiting, you get the very first error. So you don't have to wait till they hit a certain rate. The errors hit a certain rate. You wait, you get the very first error, but you get interrupted at a certain different rate. And so you just don't get another interrupt until a certain amount of time has passed. You get a representative sample of errors, including the early errors. So if I have one error per day, leaky bucket might leak that away, and I might never see it. And it might happen for months before it starts getting a little bit worse to the point where I see it. And so with rate limiting, you see that 1-a-day error, but it also handles error storms. In the case where you have just like constant storm of errors, you get the interrupt, you pull that log and clear that error, and then you don't get another error until the time has elapsed. And so what you can do is you can reason about the size of your error log and the rate that you're getting them, and design a pipeline it helps you design the pipeline because it gives you a clear upper bound on your data rates in that pipeline.
So Drew, I have a comment here in terms of what we're doing is kind of looking at errors and trying to map them to faults. So in the scenario where I have, let's say, a row fail, the first error I get is from kind of the first column of that row. But then,
well, it's whatever column you access first. Is one thing I would clarify.
well, no, but with the modern DDR, there's burst length, right? So you select a row, and then you access sequential columns back to back.
Oh, but those columns aren't necessarily starting at column 0. They're starting at the beginning column of the access.
Yes,
So
right, but
right. So you do send a column and row address to the DRAM, and then it sends the bursts back. So you don't start at column 0. That's my only point.
no, you don't. But what you get back is a bunch of columns. You send in the first column that you want, but then what you get back is a whole bunch of other columns.
Yes.
Right? So you won't be able, if you're just detecting that first error from that column, you won't be able to see the other columns are also in error. So what I'm trying to get at is, how do you, in this scenario, the rate limiting, how do you differentiate a single bit error versus, say, a row failure?
Yeah. I'll get into that. That'll
Okay.
become clear. This is really just about how you're interrupted, not about how you're counting. And so I'm talking about a partial row failure in the scenario. So I'll go through exactly that, but I'll need to get down more into the details.
Okay.
Hey,
And
Drew,
then
can we,
so I was just
Drew,
saying that the case of the uncorrectable error and they being added to a poison list is out of the scope of this scenario, right?
You mean
Poison
like
list management.
a bad page list?
Yeah, bad physical address page list.
Uh,
Sorry, address list,
I mean, it's
poison
something
list.
there's something that you might do. Well, there may not be poison because this is a corrected error, so there's no poison.
Yeah.
Uh,
So hence I'm saying it's out of scope of this, right? So since it
well,
would be
poison is
uncorrectable.
yeah, poison is. Although you could decide that I have a page with a persistent corrected error, and maybe you want to mark it as a bad page and not use it. So there's nothing that precludes that, and that's an option. So I think I cover that later in the doc.
Okay, thanks.
I'm just setting up. So okay, and so there are a few more comments.
yeah, Drew, it was just that is the third a sub or is the second a subset of third that you're enabling rate limiting after first error?
Yeah.
And
So leaky bucket is what we typically have today, and rate limiting is what I'm advocating for.
I thought leaky bucket is for rate limiting, like you leak
No,
the
no,
bucket at a certain
no,
rate.
no. This is a super important difference. So with leaky bucket, if I have 1 error per day and I'm leaking 1 error per day, my counter never hits the threshold where I interrupt. So if I'm logging on interrupt, I don't ever log that error. I just ignore it. You have to
Right. So
have enough errors.
any rate above one per day would cause accumulation and hence leaky
Well, it
bucket.
depends on your leaking rate, but my point is that you don't get the early. If you have a low rate of early errors, you don't get them with leaky bucket, and with rate limiting, you get the very first errors.
Yeah, I mean, think about it. I think about it more like polling, right? It's polling is a fixed time interval, right?
Yeah,
You poll but you have to poll regardless of whether there's an error.
yeah.
Here, it's a fixed time interval, but you only get the interrupt if there's an error, right? So like the vast majority of the time, you don't get anything, right? So it's I think about it
Yeah.
like that.
It's very much like polling, except you don't have to do the empty polls. Exactly.
Okay.
Yeah. Okay. And so what I'm going to talk about in this scenario is that there's one failure, a partial row failure in memory, and I'm assuming chip kill ECC. So I'm not uh, I'm not expecting an uncorrected error, but I want to handle it to avoid the risk of an uncorrected error. And basically what we're going to see is that we are along for the ride, right? We don't control what the OS accesses, and we don't control what the OS wrote to memory. And so we are watching things and inferring from the errors we see what's wrong. But we have to be careful in those inferences because we don't know exactly what the OS is doing with memory. So let's talk about the first, step one. Part of a row in memory fails, but the row is not presently allocated to software. So it's just a unused memory. And so I'm assuming, let's say the memory was previously zeroed, that when you booted the system, you just, you cleared memory out. That's something that's common in OSs, and, the ECC was calculated for all zeros. So if I wrote all zeros to that memory, the ECC would still be right. And then let's assume that we can correct all errors from a single DRAM, it's a chip kill, and that the ECC will see the zeros as correct data. And let's assume that the partial row that failed is stuck at 0. Okay, so we've written zeros, we're stuck at zeros, and I'm assuming multiple cache lines, because I'm assuming it's along a row, so it's going to affect multiple cache line column addresses. And so now the patrol scrubber goes through that memory, and that's kind of one of the purposes of the patrol scrubber, is to make sure that you go through all of the memory and don't let soft errors accumulate in the memory, especially memory you're not using. Because if you don't patrol scrub it, and you had memory that just remained untouched for years, the theory is that you could accumulate enough bit flips that you might cause a corrected error the first time you try to use this previously unused memory. But in this case, we're not worried about that. We have a real failure, but it's a stuck at 0. It was initialized to 0, so the ECC is calculated for 0. So everything looks good. We see absolutely no errors, even though we've had a failure. And that's my first point, is that memory errors are pattern sensitive, and so let's explore how those patterns change. So let's say that the OS allocates the memory to software, and the software writes a value with a single 1 to that failed row. So just there's just like, they just wrote a 1 somewhere in memory. They have a flag they set. This is a single bit error, and it's corrected inside the DDR5 memory. And so we'll see some stuff when we pull ECS data, but neither patrol scrubbing or demand reads see an ECC error. Okay, so we have a failure, we've written a 1, all we see is ECS, and if you're not watching ECS data, you see nothing.
What do you mean by 3B? It's corrected, like you write 1, but you have 0 there. So
But
you only have
DDR5 has ECC built into the DRAM that can correct 1-bit errors.
but it won't be able to correct it, right? You wanted to write 1.
Oh, it can't. DDR5 will correct it inside the package. So when the data comes to the memory controller, it has already been corrected.
Yeah, I mean, it will try to, but if it is stuck at, it
Yeah,
won't.
that's what I was also. You say it's stuck at.
Yeah,
at
but it
means-
won't. But it won't scrub it. But it won't. But it'll kind of corrected value.
Yeah, so it kind of a distinction to the host. That single bit error will be corrected by the DRAM. That bit cell in the DRAM, if it's stuck,
It's
there's
still
nothing.
stuck.
Yeah, it's stuck, right? But the ECS the ONDI ECC will continuously correct that stuck bit as far as the host is concerned. And the only way the host knows is to run the ECS report.
Exactly.
Yeah.
Exactly. Okay, does that make sense?
Yeah, and by the way, Drew, what I found in talking with a lot of folks on error correction code and stuff like that, there's a big misperception about ECC. A lot of people think, oh, if I have ECC, I am correcting bit cells in the memory. And what they don't realize is the ECC is correcting the bits to the host.
That's right. And you have to do a scrub to write the correct errors back. Yeah.
Exactly. And a lot of folks don't understand that.
So then the 3D is not clear. So in the patrol scrub, it's a stuck at 0, when it reads it, it will still identify it as a corrected error, right?
So no, all the patrol scrub does is it's a statement. This is why I want to go through the scenario. So I need to make some clarifications. Help me remember the same and put these questions in. But think of the patrol scrubber as a state machine in the memory controller that just says, I'm doing a read, give me some data, and then checks the ECC. And if the ECC is wrong, writes a corrected error back. So the only time the patrol scrubber is going to see anything in DDR memory is if the bits come out of the DRAM incorrect. But in this case, the built-in ECC corrects it before the memory controller sees it. So when the patrol scrubber in the memory controller accesses the DRAMs have already corrected the data. So the only way you're going to see the flipped bit is if you look at the ECS data, and even then you won't get any details. You know, ECS.
So there's like this hierarchy, CCS as it's on die, it happens first and then the patrol sees it. Okay.
Yeah, and I'll put a comment on that. And I'm trying to, since I'm walking through this, it may be hard for me to remember what I need to clarify. So, you know, Amer, please feel free to jump in and tell me what's confusing, and I will make it clear, because your questions are good. I mean, I am 100% certain that other people will have the exact same question.
Yeah, it's worth differentiating, Drew, faults and errors at the beginning of this, right? What you're talking about is a row fault, the stuck at 0 row fault that initially had all zeros data, so there was no error, but then got a single one written to it. So now that's a single bit error, even though it's still a stuck at 0 row fault, right?
That's right.
It's useful to be very crisp on the terminology that way. Right?
So move that default to D. Yeah, 1D.
This?
No.
Add
it
it's
to
just
1D. When you're saying default, it's not the
Oh, okay.
bullet one. It's sub bullet 1D.
Yeah.
That is a fault. Yeah, that is a fault.
Yeah. Okay. Yeah. And maybe I can make it bold. Thank you. This is wonderful feedback. And so hopefully you all see why I wanted to go through this is I think there are widespread misperceptions about how memory works. And if we can make a really crisp, clear thing here and refer people to it, we will help ourselves with a lot of the work we're doing. So thank you. This is great feedback.
So here, probably one more question. So any transaction driven by the memory controller to the memory, ECS will get triggered on that and will do single bit corrections.
Yes.
Okay. So if this particular transaction had more than one bit in error, that would be visible to both demand and patrol.
So yeah, and that's the key. So I'm going to highlight inside DDR5 DRAMs. That's right. It is corrected inside the DRAM. So any access we make to it, it'll be correct. Yeah, unless I think there may be some mode registers where you can turn ECS off. I can't remember, but we all pretty much have it on. So we're just not going to see it. So there's as far as we're concerned, there's no error.
Yeah, Drew, we can turn the mode registers allow us to turn off ECS, which is the reporting, but there is no way to turn off the actual on-die ECC function, right?
Yeah, and that kind of makes sense. Yeah.
Yeah.
And what you're seeing in mode that MR14, I guess the ECS, that's not. Do you want to call that we'll see error in 3C, or we'll see that as a log of a corrected error?
Well, we'll see that the row failed. I mean, the ECS shows the rows that have failures, right? I mean,
so that's what I'm trying to get right. It's a log of a corrected row, because in this case, you're right. It is also an error because you're saying it's a stuck hit, but it may not be. So this is just a log of what had happened in past, right? ECS is just giving you that.
I don't understand what I need to change, but I'm open to it. What I think I agree with what you're saying. What like how can I make this clear?
I think what Yogesh is saying is that the ECS mechanism saw the error, created a log that it saw the error, and when you poll the mode register, you find the log, right?
Okay.
So you may want to just we'll see the error log instead of error. error log.
That's right. Yeah, like again, previously the word error is being used to mean like the thing that the ECC sees, right?
Yeah.
Or
The-
the,
So
in this
now,
case,
so now you know that this had happened in past and something was done about it, but it's not giving you the current status. This is not telling you there is an error or fault there right now. It's just telling you, okay, I saw it, I corrected it.
Okay, so
Fault may or may not be there. Fault may have gone, fault may still be there. It doesn't give you any indication of fault. Just tells you what error correction was done by it.
yeah, and so and
yeah.
or does not mean that
No,
error is
yeah.
still there.
No, I don't think you need to. It's not that, Drew, right? It's again being precise on the terminology, right? Like the error occurred when the ECS mechanism read the line and detected the error, right? Like that's the error. And then it created a log of that. Just like in a x86 processor, the machine check architecture is a log of an error that was detected, right?
Okay.
Like, so I don't think you want to say things like doesn't mean the error is still there. It's just be very precise on the terminology in each of these things.
I think what you're previously saying, we'll see an error log that kind of
That's
does
right.
that.
Yeah. So this is corrected inside the DDR5 DRAM. 3C, the ECS mechanism logs the fact of the correction or something like that, right?
Logs. So ECS.
Yeah. Well, I mean, it doesn't really, but anyway.
Writes
Yeah,
to an MR, right? Writes.
Yeah, but the MR is the log, right? It creates a log that it found an error, right? Drew, like there's a lot here that's sort of missing, right? Like the ECS is independent of the correction, right? And Charlie was getting at that before.
Well,
so like,
yeah, I mean, there's a counter, right? You can see the row had an error.
Yeah. But like the way this is written, it implies that if I go read it from the memory controller, it gets corrected, and then the ECS will show me the log, and that's not true. Right? Like the ECS is a whole independent thing. It's eventually going to come around and find this thing.
Yeah, what we might want to do is create a separate number for how ECS works, because it is I wouldn't say complicated, but there's some.
Yeah, I see what you're saying. So how about this? The error will be visible via ECS.
No, you don't want to say after it's corrected. You don't want to say the error will be visible.
How about the
You
error will
already
be
say it's
recorded
corrected.
in mode registers?
Yeah.
How
At
about
this point,
say-
all you have is log. The error is in past now, right?
And by the way, another subtlety is just because the ECS catches the single bit error and writes the correct data back, if it's a stuck at, then it's going to happen on the next ECS scrub in the next 24-hour cycle. So one way to look at soft errors versus hard errors in ECS is to look at the repeating. Does the error repeat? If it does, it's stuck or hard. If it doesn't repeat, it was
but ECS doesn't have enough data to know that, really. So.
No. So this would have to be at the OS kind of.
Charlie, that's a very good point, but I really didn't want to. I mean, this is unnecessarily complicating the scenario.
Yeah.
Right? So every 24-hour cycle makes it really super hard now. Somehow, you can just put a bullet here and put that whole log thing, put a bullet and put it as a footnote or something. This is totally off the path, right? That's offline gathering of what happened.
How about this? The error is only visible via ECS.
But it may be visible via ECS at this time. Right.
No,
What,
no,
what
no.
is the what is
The
the
words
point?
that you want to use is the error log is captured in mode registers, ECS mode registers. That's all you want to say.
Okay.
Is that okay, Vilas and Charlie?
I mean, it's okay. It's just describing a wholly independent mechanism for everything from everything
it is.
else.
It still is.
Right?
Yeah, but I think
Look at-
that I'm suspecting that Drew have some reason to keep that ECS in the loop.
Well, I
which
do.
I'm
I mean,
waiting.
like in FMFM. So part of this is we're going to go through this in FMFM, and like Roy concluded, oh wow, ECS could have more data. You know what I mean? And I agree with him. But you know, it turns out he was said that like for SK Hynix, ECS was important for them to diagnose memory failures. It provided useful information. So from that purpose, I want to say, hey, there's something valuable to record there. That's all. So
Yeah, we might, I agree. I think we might actually need a separate scenario document handling the details and nuances of ECS. But for these purposes here, let's try and keep it as simple as possible. But as Vilas points out, let's be very clear in our
Yeah.
wording.
Yeah.
Okay.
And then here, Drew, do we also want to speak about a double error detection, like set dead, right? So the memory controller will correct one bit, but should create a log for a double error.
Well, no, we'll get there. We'll get there. So right now I'm walking through this in a very rigorous way. So at first we had a fault that was invisible because it was stuck at 0 and we had written all zeros. Next, I wrote 1 bit. Now I have a single bit error. It's hidden inside the DRAM. Next, someone else writes a second one, and now I have an error that I can see in the memory controller. So I'm trying to show how the OS can make write things to memory that make this fault more and more visible to us, and how we have to pay attention to the data we're collecting to recognize the pattern in the failure such that we say, oh, I've got a word line failure, I should do a post package repair. And so I'm trying to show how that might unfold in a very conservative way, saying you get as little information as you can at each step. So that I show how you have to pay attention. I think you'll.
Okay.
Yeah. In step 4, you want to point out that the patrol scrubber might see a 3-bit error.
Oh, that's a good point. And it might be 3-bit, but it
might be 2-bit, might be 3-bit.
2 or 3-bit error, 3-bit from like a miscorrection on the DRAM, but the chip kill ECC will still correct it.
That's right.
Well, in the memory controller.
May still correct it.
No, it still corrects it. So this was something that we drove very carefully when I was at Google. We raised this issue very, very early with ECS, that the aliasing for ECS when there's a miscorrection must still obey bounded fault. So
well, no, but you're mixing 2 different things. True, right? This
actually,
example stipulates chip kill ECC, so the aliasing doesn't really matter, right?
Well, yeah, although you could say it's a wider bounded fault chip kill, but sure.
But whatever. But yeah, it's just.
I'm not mentioning that subtlety, but in the doc, trying to keep it simple. But that's my mindset.
Yeah, it's okay. It's okay to keep it simple. Yeah, leave it at that. No need to get into those.
So now, when you look at this, if polling will see this here, leaky bucket probably won't interrupt for this because the rate is too low. You know, like, because I'm saying, let's assume that software is not actively using the cache line, so only the patrol scrubber sees it. So we get one error every 24 hours. That's probably too low. Leaky bucket won't see it. Rate limiting well interrupt and log the error. The memory errors then, would be, I'm assuming RAS API, would be placed in the RAS API error logging queues and delivered to analysis tools. And it doesn't really matter. I don't really care if
the polling software will see the error.
Yeah. Because you poll the you poll the patrol scrub as well. At least when I've done it, I've just polled the memory controller for errors, and so it'd see the patrol scrub logged errors or the demand scrub logged errors.
Okay, I see. You're talking about the second write. Okay.
Okay, and so then assuming the CPR is sent to the analyzer only knows that a particular cache line address is failing. That's it. And we don't have really any information to assume anything else. Even though the fault is bigger, I can't really infer that. All I've got is I got a failure at one place because that's all I'm seeing. Okay, now let's say the OS starts reading the same partial failed row and it just has the 2 bits in the one place. So we still only have a couple bits that are detected by the ECC. And the patrol scrubber and demand scrubber start seeing the error. And the visibility is patrol scrubber will see the error. Leaky bucket won't see these errors if the rate is low, because I said but infrequently. And so it'll set, they're usually set high enough to prevent storms. And so, maybe we don't see the error here. And rate limiting will see the error. And then CPR is sent to the analyzer. And now we know that we've got a bad address and we've seen it repeat. So, we might suggest mapping a bad page out. We might try a soft PPR just for that one cache line. But let's assume that we don't want to waste our PPRs. And so, let's just wait and see what happens when more bits are flipped. So now software writes ones to another cache line on the same failed partial row that's used now. It's used frequently by software. Now we've upgraded this to a potential error storm because it's used frequently. So every time you read it, you're going to see a corrected ECC error. But here's the thing.
But Drew, but even with the one cache line, there's a potential error storm.
Well, there is, but I clarified that it was infrequent.
So, but if you're using,
I see. Fine. Okay. Well, yeah, it's just not clear, right? Like you say, it's another cache line that is used frequently, so it's unclear that the error storm is due to the frequent use, right? You need to clarify that. Okay.
Yeah. Thank you. That's a really good point.
Yeah, question. So when we get an error storm, what information are we able to gather if the interrupts are not fast enough, right? So we see an error, but what information beyond that do we get?
The interrupts are never fast enough. Yeah,
they're never. I mean, like you can have more errors than you can handle in the interrupt, right? Because the interrupt runs
Right. So a storm could actually be one stuck bit that's just being read continuously, right?
That's right. It can be a billion errors in a very short period of time if you're using if that line of thought.
Okay. Got it.
That's kind of that's kind of the point I'm going for here. So yes.
Yeah. Okay.
And go ahead, Vilas.
Yeah, no, I mean, but Charlie's, poking at a good point here, right? Like, I almost think you should address the error storm stuff separately because it makes it feel too much like, oh, I only get an error storm when I'm accessing more than one line, right?
Yeah.
Okay. And so I think maybe just have that as a separate top bullet and say like, hey, keep in mind if software goes and accesses frequently, then we have, and just have that as a separate thing.
Yeah,
I get another scenario document if we want to expand it enough. Because
I can just make another case in here. It's no big deal.
Okay.
I agree with what Vilas said, and you're raising a good point. So I'll fix that.
Yeah, I hear so much about error storms. I've been hearing about air storms ever since I was at Sun, and I don't completely understand where they're coming from or what the different sources could be. It just seems like black magic.
No, it's not.
It's
Simple. It's simple. It's an interrupt storm. It's not actually an error. It's an interrupt storm, Charlie, right? It's just interrupt, like
right.
software. The system is accessing the faulty location and seeing errors at a faster rate than the interrupts can be processed.
Vilas, thanks. I can get my mind wrapped around that. What I hear from the FA engineers and the field service engineers I talk to, they can't even get down to that level. All they can say is, the customer saw an air storm. They want to replace this. And if I ask more details, it's like, they saw an air storm. What more do you need to know?
Yeah.
And the reason for the air storm can be very interesting. It could be
exactly. And that's for many, many years I've been trying to dig at that, but now maybe I'm making a little progress.
It's the cost of the interrupting, right? That makes them want to replace it, because that usually ends up affecting performance of whatever.
But is the performance only because of interrupts, or it should be the memory also, right? Because the error logging and handling the error also takes away time from memory, right? So that
continuous correction also is
that performance impact is bigger than probably just handling interrupts.
It depends on the architecture or the implementation of the underlying error correction. All of those things can be mitigated, including the interrupt.
Thank you. Yeah.
So good. We have 3 minutes left. And one thing I wanted to clarify is I only saw the top bar. I thought there's only like 5 people in the meeting. So that's why I was thinking, well, we don't have enough people, but this is good discussion. I don't think we will be able to finish it today.
Well, I think there's plenty to cover. Why don't I fix the comments that I know of, and then we'll review it again. And thank you for all the feedback. I hope you see the value of what I'm trying to do. I think that and I'll try to, I said can impact performance. Demand scrubs can impact performance. Interrupts can impact performance. Actually, I'll just say that. But what I'm hoping is that we can make a document that we can point people to, and it will open their eyes to some of the challenges in understanding memory. And my goal is to explain why I love why I love rate limiting, and why we need to look for patterns in errors and not just count them, because I'll go back to making the single bit error be the error storm and emphasize that it's going to be corrected. Like, it will not cause a crash anytime soon, but it might make a customer mad because it could affect their performance in some cases. And so this is super helpful, and I hope it helps you. My goal is to give you all a reference that we can all point to help each other explain to teams why memory error analysis is more subtle than they think.
Thank you, Drew. I'd love, when we get this completed, I would love to share it with the Cisco engineering teams. It'll really open their eyes.
Cool. And thanks you for all the great feedback. It's great having people like Yogesh and Vilas here keeping me honest. So thank you. And Amer, your questions are great too. All of it. It's super helpful for me to get your feedback on this.
Very educational session, I must say. Thanks.
All right. Thank you, Suke. I appreciate that.
Thanks all.
We'll continue next week. And if there's a better way to do this, let me know. But otherwise, I want to just have a really really increasing scope of damage walkthrough of a particular one failure.
I think. Go ahead, Yogesh.
No, I was just going to say, drop the link one more time in the chat window. I think some folks joined later, or maybe I didn't see them. But yeah, I think this is great.
Okay, I will drop it right now.
The only improvement I would make, Drew, is we could have this on a daily basis.
Hey, you
sponsor the lunch, Charlie. I'll show up.
So what I would summarize is this is why we want FM. It's kind of I should make that a subtitle. It's like, this is why FM is good.
Yeah,
is that those folks understand this intuitively.
Charlie, I think we need to have like some kind of college course for this kind of like RAS material. You can go that deep into it for one, RAS 300 or something.
Yeah.
I've been arguing that, and I'd love to build some course material along those lines. I mean, we do need that, and we need to train more people to think this way about error handling, so that
there
we
are
get
college
better
credit
results.
courses for reliability, Drew. But there could be trainings and vocational, mindshare type stuff.
Yep.
But this is kind of the foundation. This is the foundation to doing that, right?
Yeah. And Charlie, that life of an error talk I want to do with you at IR next year, it's stuff like this that I think is interesting to go through.
Yeah. Great stuff. Thanks, Drew.
All right, to be continued. And Drew and I argued about it in Arizona a couple of days ago. So, okay.
And Yogesh, I think next week what we'll do is we can try to finish this, but also if we can get through Anil, Anil's edits to if we can get some of the main spec wrapped up so we can publish it, that would be good too. So, I'm flexible. I'll keep working on this and take feedback, but if we need to wait a while, that's okay too.
What sections should we target? I'm sorry, guys. I wasn't here last week. So.
I think just if I go back here, I think Anil had added some comments, so we want to go over the sections that have comments, and then I think I cleaned up I cleaned out some of the stuff that was blocking us, but I think we need to kind of look at the end here, and industry enablement, and then some of these PCI flows. I don't think. And I think I'm going to move crash dump into the best practices doc too. So I guess what I would say is let's look over the doc and see if we can converge on what do we need to get this thing published. Because I think it's time. I think we're like just this far, just slightly got a couple more things to nail, and we can submit this. I'm hoping.
Are there any sections that are still open or not completed yet, or just?
I think then the scenarios, the PCIe corrected error flow.
Okay.
And that's it. And I'm going to move the crash dump into the best practices doc. Which is I'm calling this, I'm sorry, I didn't mean best practice. I would call it scenarios. So I'll make sure there's a crash dump scenario. Yeah, there's a crash dump flow. And I'll make a doc and give it to Rama. I'm just teasing. I'll joke with Rama, but yeah. Okay. Well, thanks so much. I really appreciate your time, and I feel like this is awesome. We do have something special in this meeting, so I appreciate you coming. I mean, it really helps to get the mind share.
Hey, thank you all. Great discussion. Thank you. It was wonderful.
Okay, thank you. Have a great weekend.
Bye.
See you.
Bye.